students, this is my Mathsplanation for question 3 on Kognity task 4 from our October 13th class. This is another multiple choice calculator question, and it asks, a parabola with the equation y equals a times the quantity b minus x times the quantity x minus c is concave up if. I show the answers. It again highlights the correct one in green and explains the rationale. But because this type of question can be confusing to students because of using variables that are general instead of specific numbers, I want to connect this proof that the author has put forth for you with the graphical example. So again, connecting the visual to the algebra, and show you where in the book chapter references this material. So first, I'm going to go back to the book and on this section for standard form. Way back in the very beginning, the book talks about when a parabola would open upwards and be called concave up. And normally when you have a quadratic function in the form ax squared plus bx plus c, just looking at the value of a would tell you whether it was concave up or down right away. To toggle back very quickly and point out that what the author does here is distribute, which you might have also known as FOIL, to get the equation in standard form. So that is why this negative a would have to be greater than 0 and cause positive a to be greater than 0. What I'm going to do using the graphic display calculator is to show this with an example, because that can often help students understand the reasoning behind the general proof. So I'm going to select for A -2, because we know the correct answer is that A is negative. For B, we'll do 5 because there were no stipulations on what that had to be. And then for C, I think I'll pick 3. When I hit graph, I do see a concave up parabola. And I'm going to show you in Y2 what would happen. And I realized I used the wrong sign. I didn't want a negative. If I do want the negative, x minus 5, not 5 minus x. That's a very small change, and that's normally what you would see for factorized form. When I graph that, you can see that the parabola is concave down, and this is a way of showing, using an example, what this general form defines. Some other notes to disprove the B and C are positive. In Y2 here, well, actually, I should make another one. I will. If we make the A equal to 2, so now it's a positive value. And then I have both B and C being positive. I'm going to do 5 minus x and x minus 3. Graph. Lo and behold, this equation is actually the exact same as Y2, and it's concave down. So that's one counterexample to that both B and C are positive. do one more and show that if both B and C are negative, what can we do here? So I'm going to put in -2 again for A because we know that can force a concave up. And do -5 minus x times x minus, well, I'll do minus means plus. Oh shoot, that does actually work. That one does work. Now, I have to make one that does not to prove it to you. So if I do the same exact thing, now instead of making it 2, I can make it 6. Do -3, actually clear that, 6 times -3 minus x times x plus 4. That forces a concave down, so that makes a counter example. So pardon the hiccup in the explanation, but I just wanted to get you to have the idea of why choice 1 really was the correct answer.